So hello everybody, welcome to our IGENIS webinar. Our focus today is going to be optimizing antioxidant support pathways. So I'm going to be giving you a bit of a review of antioxidant support pathways. No particular focus on particular conditions or health areas as such, but just really kind of an overview of some really good quality antioxidants and other nutrients really that all kind of intertwine and sort of play a role in making sure that our antioxidant capacity is top-notch. Okay, so just as a bit of an overview, and I'm sure you all know this, but when we're talking about the sort of inflammatory process, so it's this sort of mechanism that is very well known, and it's there really to kind of maintain health and immune homeostasis against the sort of potentially thousands of the sort of environmental and other attacks that we are exposed to. I was going to say on a daily basis, but it's like a constant process all the time. So we're constantly sort of having this sort of support and sort of battle within the body, if you like. When the inflammatory response is not properly regulated, amounts of inflammatory markers tend to rise, remaining high, and this leads to this sort of physiological status that we know as low-level chronic inflammation. So it's not necessarily symptomatic as such, but it's kind of sort of sitting inside us, sort of like eating away at everything and predisposing us to poor health. And this inflammatory process induces oxidative stress and reduces our cellular antioxidant capacity, leaving all these sort of nasty free radicals to react with our cell membranes and proteins and fatty acids. And this has a myriad of consequences within the body that ultimately predisposes us to a variety of age-related disorders, including diabetes, autoimmune diseases, neurodegenerative diseases, and so on. So, as I said earlier, we are constantly exposed to free radicals. So we either make it endogenously as a normal sort of process of metabolism, for example. It comes from sort of environmental pollutants. It comes from things like smoking, radiation. You're all very familiar with this, so I don't really need to go into too much damage. But basically, we are bombarded on a kind of all the time. So it's really important to make sure that our antioxidant processes are functioning optimally. However, on saying that, and we're talking about sort of free radicals and reactive species, which can be either oxygen or nitrogen based, they are constantly being produced, but we need to just sort of clarify the fact that actually they have a very important role in sort of human physiology, and they contribute to a number of really important functions such as initiation and regulation of apoptosis, activation of transcription factors, expression of genes that code for antioxidant enzymes, and so on. So we need a certain amount of reactive species, so that we can deal with the sort of processes that go on a daily basis. But it's when we have excess ROS that are not quenched by our lovely antioxidant system that things go rather awry. So in my little diagram there at the bottom there, so we need a certain amount but not too much. And then we kind of think about how sort of oxidative stress and inflammation are interrelated as well. So we know that oxidative stress causes inflammation, and inflammation causes oxidative stress. So there's this kind of continuous sort of spiral of events that are going on. And so we need to ensure that our endogenous antioxidant support is kept in check, but we also need to be supplying plenty of antioxidants through the diet itself. When we have large amounts of reactive oxygen species, then we start to see things like activation of transcription factors, and I was talking about sort of requiring these, but overactive things like overacting overactivating nuclear factor kappa B, we then get an increase in our pro-inflammatory gene expression. We get pro-inflammatory end products, cytokines, chemokines, and so on, that if not kept in check leads to this state of chronic inflammation. And again, as I said, associated with aging and age-associated diseases. However, our bodies are wonderful, and we are armed with a wonderful supply of internal antioxidants, so endogenously made antioxidants, and obviously, you know, we consume antioxidants as well. So we have this capacity to either prevent, inhibit, or repair the damage that is as a consequence of formation of reactive oxygen species. So as long as we're supplying and looking after all of our lovely pathways, then everything should work functionally and properly, which is not always the case. So we have, as I said, our endogenous enzymatic antioxidants, things like superoxide dismutase, catalase, glutathione, peroxidase. And then we've got our dietary antioxidants. We've got water-soluble antioxidants. We've got lipid-soluble antioxidants. And I'm going to explore a few of those a little bit later on in the webinar, and how they all interact with each other. So it's not just a case of, you know, I take a antioxidant and everything will be hunky-dory. Doesn't really work that way. So there's this wonderful synergistic relationship that goes on between both dietary and endogenously made antioxidants that help to sort of support, prevent and repair. And there's also a bit of a hierarchy as well. So our primary antioxidants, so these are our endogenously made, so these are, you know, things like superoxide dismutase, catalase, and so on. They have the most effective, or they deliver the most effective protection against oxidative stress. And then as we go down the pyramid here, so we sort of go down further and further, and the sort of vitamins and minerals and things like that are down at the bottom. These are our secondary antioxidants. Doesn't mean that they are not important. It's just kind of more referring to their capacity to deal with oxidative stress. So, for example, vitamin C and vitamin E can maybe deal with one molecule of free radical, whereas something like CoQ10 or astaxanthin, which I'll talk about a little bit later on, can deal with multiple molecules of oxidative stress. We get this sort of process of different antioxidants giving us a variety of protection. Okay, so, and our antioxidant defense system has to be widely dispersed as well, because we are sort of, you know, we're attacked from all sort of areas. So we have different antioxidants, different areas of our cells. So we have things like CoQ10 in the mitochondria, glutathione peroxidase in the mitochondria. We've got vitamin E, we've got vitamin C within sort of cell membranes, or sitting inside and outside of the cell membranes. We've got astaxanthin, which spreads across the cell membrane. We've got antioxidants within the cytoplasm, within the nucleus. So there's this good array of different support networks offering a variety of different areas of support and protection against reactive oxygen species. And just to kind of expand a little bit, so I'm not going to go into this slide in a huge detail, it's just to really kind of emphasize different antioxidants, different locations, different properties, different effects, and different kind of like levels of effect as well. So we need to ensure that we have a good variety and mix of antioxidants or cofactors that help support and protect these antioxidants. Best place to get your non-endogenously made antioxidants, so those from the diet, is from the diet. And of course, everybody is familiar with the Mediterranean diet. So we have our kind of foods, if you like, down the left-hand side, and then we can kind of split those up, and we can start looking at things like vitamin D, vitamin A, C, minerals, omega-3s, all of these wonderful nutrients that then kind of go on throughout the body to sort of help support a variety of different sort of areas. So anything from sort of cell membrane integrity, methylation, so things like BVITs and stuff like that, but sort of reducing things like oxidative damage, neuroinflammation, and free radicals, you know, down there on the bottom is really, really important. So the Mediterranean diet, as do several other diets, but we'll just sort of focus here for now, offers us the correct or a good balance, mix of all the different sort of macronutrients and micronutrients that are required as the, you know, even as sort of like building blocks for the enzymes and the antioxidant support networks that we need to ensure good health. And there have been several, I say several, there have been a multitude of studies focusing on the health benefits of the Mediterranean style diet. And most of it sort of kind of focuses on the sort of antioxidant, immune supporting, the anti-inflammatory benefits that are attributed to this diet. And this is just to kind of emphasize here, this was a study that was published 2013, and it was really looking at what was called what is called the non-enzymatic antioxidant capacity of a diet. And it takes into account all the antioxidants that are derived from food and their synergistic effects. And so the intake of the antioxidant-rich foods increase the sort of blood levels, if you like, of this sort of antioxidant capacity. And the outcome, I'm not going to go into it in huge detail because there's no need, but the emphasis really is that if you follow a Mediterranean-style diet for a year, we can see that it increases our plasma total antioxidant capacity. So if you put the right fuels in, then you will protect the body from this sort of barrage of free radical damage. And it's this kind of emphasis really on increasing antioxidant sort of stores, if you like. Okay, so let's have a little look at some of our antioxidants. Okay, so glutathione, or reduced glutathione, is actually considered to be one of the most important scavengers of ROS, and its ratio with its oxidized version gives us a really good indication of how much oxidative stress there is in the body. Reduced glutathione shows antioxidant effects in several ways. So, for example, it detoxifies hydrogen peroxide and lipid peroxides through the action of glutathione peroxide, the enzyme. Acts as a cofactor for several detoxifying enzymes. But again, there's this sort of synergy effect as well. So glutathione is involved in converting vitamin C and vitamin E back into their active forms. So, and this is really important actually, because a lot of antioxidants, unless they're converted back to their active forms, actually have the capacity to become pro-oxidants. So you need this kind of like mishmash of different antioxidants to keep this kind of like cog system turning, if you like. So one antioxidant or one antioxidant will reconvert a pro-oxidant back into its active form and so on, and that allows then that antioxidant to then go off and sort of do this sort of an important function. Glutathione is also important in regulating the activation of several transcription factors such as AP1, nuclear, NF-kappa-B, all involved in antioxidant pathways and inflammatory pathways as well. So glutathione has a multitude of roles. And it gets depleted really quickly. So if you have very high levels of oxidative stress, then your glutathione levels will get depleted quite quickly. One kind of classic example of depleting glutathione is if you happen to go out with the girls, if you like, have a few drinks, next day your glutathione levels will be quite low, should we say. Okay, so one of the really important things, because we know that glutathione is produced from cysteine, which is produced from homocysteine, is to support your methylation cycle. So elevated homocysteine levels, we know, actually causes oxidative stress in itself, but it also impacts us by reducing our glutathione production pathway. So if homocysteine levels get stuck or accumulate, and we have low levels of things like vitamin B6, B12, magnesium is another one, then we can impede this, the transsulfuration pathway. So we get low levels of glutathione. The methylation cycle also supplies methyl groups for a number of other methylation dependent reactions. And one of these, and I've underlined it, is the manufacture of coenzyme Q10. So again, this is another endogenously made antioxidant, also involved in energy production as well, ATP. But coenzyme Q10 is a major antioxidant, especially within the mitochondria itself. I've got a couple of slides later, so I'll go into a little bit more detail there. But if your methylation cycle is compromised, then this is going to have an impact on your CoQ10 levels, especially if you're not consuming it through the diet. So if you're not eating plenty of kind of like organ meat, liver, things like that, then it's likely that your CoQ10 enzyme is going to be compromised. And so if we have compromised methylation, we see an increase in oxidative stress, again, going back to our kind of accelerated aging and increased risk for poor health and disease. So one of the focus is on increasing our glutathione levels. If we can do that, we can look after a number of pathways. We can do this quite easily through making sure that we consume plenty of cruciferous vegetables, sulfur-rich foods such as onions, garlic, and so on, cysteine-rich foods, soya beans, tofu, obviously because glutathione is made of cysteine, glutamic acid, and glycine, with cysteine being the kind of like rate limiting, is the most important amino acid there, so it's the most important building block of glutathione. So this is why we need to eat lots of cysteine-rich foods. And again, if you can sort of keep these vegetables and these nutrients, I mean, it's not appropriate all the way throughout, but things like your vegetables, eat them raw. You're going to look after your enzyme levels within the vegetables themselves, but you're also going to be keeping all the other important nutrients, the enzymes, the vitamins, the minerals in their native active kind of state, so that they're undamaged by cooking processes. Okay, another way to look after our glutathione levels is through supplementation with acetylcysteine. Not only does it have a direct antioxidant capacity itself by promoting glutathione synthesis, but it actually has a number of other wonderful benefits within the body as well. Inhibits oxidation of things like cholesterol. It reduces homocysteine levels, and it also has this sort of wonderful synergistic relationship with other antioxidants as well. So again, it works alongside things like alpha-lipoic acid, glutamine, vitamin C, vitamin E, which are all important in the regeneration of glutathione. For example, and you can see that at the bottom of the slide here, vitamin C is really important in converting oxidized glutathione into its reduced form, and vitamin C then has the same effect on vitamin E has the same effect on vitamin C. So there's kind of like, it's like a baton race of kind of recharging each other. So this is, again, for those of you who have attended my webinars in the past, you'll have seen my wonderful diagram here. So I've highlighted in green our cysteine and our glutathione, and then at the top there in our methylation cycle, we've got things like folate, B6, B12, magnesium, zinc, all play a really important role in making sure that all of these pathways work really efficiently. Because if you get a clog up in any kind of area here, so if our levels of magnesium are low or our B-vits are depleted, then it's going to impact on other pathways and other sort of branches off of the pathway. So as long as we kind of keep everything functioning nice, tickety-boo, our cysteine, our glutathione levels will be looked after. We'll look after our antioxidant production, detoxification pathways, inflammatory regulation, and so on. Okay, so I was talking about kind of like supporting antioxidant pathways with vitamins and minerals. And I think the next couple of slides is really to kind of emphasize how compromised, even if you just sort of kind of knock out one particular nutrient, how it can have a sort of knock-on effect down various pathways. So I've kind of talked about glutathione. Now, reduced glutathione, which is the active form, becomes oxidized, therefore it's deactivated during its antioxidant activity. So it's kind of throwing its sort of protons away and things like that. And then it has to go through a process of reduction, and it requires the enzyme glutathione reductase, and that through that process it then regains its antioxidant activity. Now this enzyme requires riboflavin in the form of fat, and this kind of emphasizes the role of one particular vitamin, so that will be B2, riboflavin, in the formation of the reduced active form glutathione. So if you don't have enough vitamin B2, then you're going to have an impact down this line. Now, what's also quite relevant is that riboflavin B2 is also a cofactor for pyridoxine phosphate oxidase, which is required to produce the active coenzyme version of pyridoxal 5-phosphate from B6. This is a cofactor for a couple of enzymes. The enzyme that converts homocysteine to cysteine, and then cysteine to glutathione. So you kind of start to sort of get this picture of why certain nutrients are really necessary, and how if you kind of like just knock out one particular nutrient, it can have this kind of long knock-on effect on other pathways. And this is why I will quite often, this is just a quick slide here to sort of show you this sort of synergistic relationship that actually just goes on between B6 and B2. So if you knock one of these out, or if you don't have enough of one of these in your diets, or if you're depleting one of these, then it's going to have a kind of a knock-on effect. And again, low levels of riboflavin. I mean, this is just really kind of an example. I could talk for England about all the different sort of nutrients, but this is just really kind of to emphasize how important it is to make sure that levels of all kind of nutrients are really kind of looked after. So even just knocking out something like riboflavin is going to impact things like glutathione production. It's going to have an impact on nuclear factor kappa B. It's going to have issues at the kind of mitochondrial level, and so on. And then obviously at the bottom there, it kind of has an impact on B6 activity too. And that's why it then leads me into my next slide, which is when people speak to me and they say, okay, so how do I look after my antioxidant pathways? And I say, well, make sure, the first thing is make sure that you're taking a really good B complex, because hopefully, as I've kind of explained, if you're not looking after things like the methylation cycle, then it's going to have a knock-on effect on certain sort of endogenously made antioxidants. So this is, again, many of you will be familiar with some of our products, but this is our Super B complex. And again, we kind of focus on supplying the active forms as well. So as you can see there, our B6 is pyridoxal 5-phosphate. So this is the one with cofactor activity. And again, sort of pre-methylated all the way. So in terms of methylation support, Super B complex is a good product to start with. Okay, so leading on into another area of looking after or protecting against oxidative stress is the polyphenols. Okay, so I think this slide kind of just says it all. The more more diverse your diet is in terms of color and plant foods, the more polyphenols you will be taking into your body. So, you know, the purples, the greens, the yellows, the oranges, the reds, the more vibrant and the more colorful, the more nutrient rich it's going to be. So not only is it going to be rich in polyphenols, but you're also going to be getting, you know, a good supply of vitamins, minerals, all these kind of cofactors that we need for antioxidant support pathways. So our polyphenols, we can divide those up. I'm going to talk about a few, but I'm not going to go into a huge amount of detail on them. Some have a lot more sort of evidence in terms of human studies than others, but we look at things like curcumin, resveratrol, quercetin, EGCG, even the soy isoflavones. They're all kind of very, very well documented in terms of supporting antioxidant pathways and having their own unique benefits as well. So again, split them all up and we can see how, I mean, some of the names are absolutely amazing and I'm not even going to try to pronounce many of them, but we can see that, you know, again, it's going back to making sure that we have a diverse diet that is full of color and potentially, if you can, you know, as raw as possible. So we can see that our diets can be a really good, rich source of polyphenols. And again, polyphenols, wonderful nutrients, have been shown to, through kind of upregulation of phase 1 and phase 2 metabolic enzymes involved in sort of detox. So again, protecting against oxidative stress. They regulate inflammatory pathways, again, so COX-1, COX-2, which are involved in sort of prostaglandin production, nuclear factor kappa B, our major transcription switch. They inhibit cell proliferation, induce apoptosis, and so on. So it's not surprising that the kind of research around polyphenols shows huge benefits for decreasing inflammation, protecting against oxidative stress, as well as kind of benefits for things like brain health, cardiovascular health, diabetes, and so on. And one of the really kind of key areas as well, and so sort of backtrack slightly actually, one of the major mechanisms in sort of cellular defense against oxidative stress is activation of something called the NRF2 antioxidant response element signaling pathway. So this is a pathway that controls the expression of genes whose protein products are then involved in either detoxification pathways and therefore the kind of elimination of reactive oxidants through various kind of conjugated part reactions and so on, but literally kind of by enhancing cellular antioxidant capacity. So and this is one of the kind of real key functions of polyphenols, actually. So this is attributed to things like curcumin, resveratrol, EGCG, found in green tea. So all of these wonderful polyphenols, they upregulate our antioxidant enzymes. They have benefits for things like glucose control, insulin sensitivity. They are heavy metal chelators, resveratrol in particular, anti-inflammatory, but they also have kind of direct antioxidant actions as well. So this is really kind of good groundwork for ensuring our diets are rich in a diverse array of polyphenols as well. And another, forgive my busy slide, but this is the only slide that I could actually find that showed, and the focus here is on vitamin D. So we're all aware of the kind of messages surrounding vitamin D at the moment that have been going on for the last year or so. We're all sort of fairly sort of depleting vitamin D. We don't get enough vitamin D in our diet. We're not getting exposure to vitamin D. And vitamin D, we talk about, you know, bone health and calcium homeostasis, but actually, and this is kind of focus here, so I'll just get my little mouse out, is that vitamin D actually plays a really significant role in this sort of detoxification pathway, so the NFR2 sensitizing process. So ensuring adequate intake of vitamin D. So, and again, we're kind of being recommended that we should be supplementing rather than relying on diet or from sun exposure as well. So, I mean, we've known for a long time that vitamin D is involved in things like calcium homeostasis, vascular processes, even through to things like sort of amyloid beta and tau accumulation, which is our sort of major risk factor for things like Alzheimer's. But actually, its role in sort of looking after our oxidative stress pathways is really, really important. So plenty of vitamin D. And usually kind of, you know, supplemental form is going to be the most effective way to get your vitamin D levels up. Little slide here, talked about resveratrol earlier. Not only is it really useful for kind of scavenging oxidants, but it's actually a major chelator of heavy metals as well. So huge amounts of benefits for getting resveratrol in the diet, resveratrol supplements as well. There's increasing evidence for a sort of a protective role for against things like neurodegenerative sort of diseases and things like that. Our little green tea extract, so EGCG, again, we've got our little NRF2 down here. I think the other NRF2 was the other way around in the last slide. Forgive me for that. So again, I mean, this is just to sort of emphasize the diversity that one nutrient has, or the diverse roles that it has within the body. So this is just a kind of, you know, the impact that EGCG has on things like protein kinases, apoptotic proteins, growth factors, but its role in sort of transcription factors and sort of the activation of sort of antioxidant response elements, signaling pathways and things like that. So starting your day with a nice cup of green tea doesn't sound such a bad idea after all. And again, this is just a little slide which I've kind of shown before, I think, when talking about the benefits of green tea. Be a little bit picky about your green tea, where you're getting it from, the type of tea that you have. Loose tea is better. Green tea leaves are not fermented, and so they've got the highest amount. Be a little bit cautious about how much caffeine you're getting, because you don't want to overdo that. But yes, so different teas, different qualities, different levels of EGCG. So good quality tea, maybe 2, 3, 4 cups a day, you're going to be getting a good level of EGCG into the system. Okay, so this is my kind of emphasis on antioxidants working synergistically. As I've said earlier, I kind of built this sort of image of this sort of cog system. And it's like, you know, you turn the wheel on one, and it sort of starts to activate something else. So all of these antioxidants go from oxidized to reduced to oxidized, and they're all dependent on each other for these actions. So if you start to sort of deplete one or two or several, or you don't have the capacity to make your endogenously made enzymes, then you're going to start to sort of put a bit of a spanner into the works, really. And when it comes to certain vitamins and minerals, and I've picked out a paper here to really kind of emphasize it, is that consuming So in this example, it's going to be vitamin. So I'll just talk about vitamin E and vitamin C and sort of intake and sort of plasma levels and status. So you can have two individuals taking exactly the same amount of sort of antioxidants, say vitamin C, doesn't necessarily mean that their plasma levels are going to be the same. And there is a big role in genetics in explaining some of the variations that are involved in things like uptake, distribution, metabolism, transport, and so on. So this was a study that was really kind of highlighting this. So it's thought that about 22% of the variability in circulating levels of vitamin E, for example, can be attributed to variations in key genes. And this goes towards explaining some of the kind of like weak correlations between intake and circulating concentrations. And again, it's very similar for vitamin C as well. So vitamin C is absorbed primarily in the small intestine by active transportation via the vitamin C transporter type 1, which is encoded by a particular type of gene. And it's polymorphisms in this gene that are associated with circulating concentrations of ascorbic acid, vitamin C. So I think this is important really, because when we're kind of like doing our research and we're trying to find out, you know, what nutrients are best and, you know, sort of dose and effect and that kind of thing. And we quite often see sort of controversies arising in dietary intervention studies. So, you know, you're kind of all aware of the sort of headlines that come out, you know, oh, this intervention for over 2 years of this vitamin or this mineral, absolutely no effect at all. But actually, if we start sort of like looking and sort of delving into it a little bit, we can start to sort of clarify why some people maybe need a little bit more than others. So we might not necessarily know what our genetic makeup is, but this kind of emphasizes why we need a diverse intake of different vitamins, minerals, antioxidants, and so on, rather than just kind of relying on one alone. Okay, so yes, this is our little vitamin C function and uptake slide. And, you know, these kind of like high dose vitamin C supplements that I see all over the place, I've never really kind of understood them. Low doses of vitamin C are almost completely absorbed. If you take more than a gram a day, then your absorption falls to about 50% or less. Absorbed or unmetabolized ascorbic acid is simply excreted. So actually taking small amounts of vitamin C regularly throughout the day is going to lead to higher blood plasma levels than taking, you know, mega doses of vitamin C. And this is quite common for other nutrients as well. It's very similar for B12 taken orally, for example. So small amounts over the day, split dosing if you're supplementing, increases your blood plasma levels most effectively. Okay, so sort of various sort of supplements, vitamin C supplements, for example, look at ways of improving uptake and retention. So, for example, vitamin C in the plasma is reflective of recent intake, but vitamin C within the white blood cells, so leukocytes, for example, tends to be more reflective of tissue stores. And therefore is going to be, if vitamin C is retained in leukocytes, it's going to be sort of influencing our immune function as well. And there's quite interesting data on things like ester C. So this is a unique patented form of vitamin C that has been shown to accumulate in leukocytes more effectively than standard ascorbic acid. So there are some kind of benefits. So ester C appears to improve the retention of vitamin C compared to standard ascorbic acid, and so basically less is excreted. So if you're looking for sort of vitamin C as a intervention, or if you're wanting to increase your vitamin C intake, then either taking standard vitamin C, small amounts over the day, or looking at sort of optimizing the delivery with something like ester C. Other forms of vitamin C include kind of like nanotechnologies, so solubilized, for example, have also been shown to sort of improve the uptake. Right, okay, back to the polyphenols just for a moment. So just to remind you of all of our wonderful polyphenols. Now, one of the issues with a lot of the polyphenols is that they have to be taken in relatively high amounts because the benefits are often limited by things like poor bioavailability. A lot of them are sort of low solubility, and they tend to have low absorption in the gut. So for curcumin, for example, quercetin as well, I think is another one, is processes of things like glucuronidation, sulfation by the intestines and the liver, render them water soluble, and basically that improves the efficiency of excretion via the kidneys. So we either lose through sort of kidney function, or anything that sort of isn't metabolized and sort of absorbed is just sort of passes straight through the system. Yeah, okay, so yeah, quercetin is one of the sort of key ones here. So quercetin is wonderful little bioflavonoid found in green fruits and veg. It's really good for sort of like looking after gut function and things like that, or wonderful antioxidant. But actually the absorption is relatively low, anywhere from between about 3% to 17% in healthy individuals receiving about 100 milligrams. And again, it's all about absorption, metabolism, elimination. So it's understandable that a lot of technologies are sort of recognizing the benefits of certain polyphenols, recognizing the fact that actually if a majority of it is actually just passing straight through, then it's not really going to be having much of a function. So let's have a look at some technologies to protect our polyphenols from things like the acid environment of the gut, to improve their uptake, to make sure that blood plasma levels are at a level that's actually going to be effective. One of our favorites, and you're probably all familiar with our curcumin product. Curcumin's been around for an awfully long time. And one of the issues with curcumin, obviously, as I've mentioned, is that the process of glucuronidation and sulfation by the intestines and liver tends to throw curcumin straight out of the system. So one of the best delivery systems, and this is the delivery system that we use, is long vida optimized curcumin. So you kind of get this like it's called a solid lipid curcumin matrix, lipophilic matrix that kind of surrounds and protects the curcumin, delivers it across the blood, through the gut, and also across the blood-brain barrier as well. So by doing this, we actually avoid the liver completely. It's transported through the lymphatic system rather than the circulatory system, and we get higher levels of curcumin. And it retained in what is known as its free form. So the free form is, it's in its most simple terminology, it's the free form. And if you can get your curcumin levels up to a good standard, then we're going to start to see the benefits. So antioxidant effects, we see metal chelation. We get a decrease in COX-2, so this is our enzyme that's involved in producing prostaglandins from arachidonic acid, and so on. So we get all of these wonderful benefits, but enabled for us to reap the benefits, as it were, we need to make sure that curcumin is absorbed and retained. Okay, so one of the other benefits of curcumin is this ability to, as a ROS scavenger, but also in its ability to upregulate antioxidant pathways as well. So we're looking at sort of glutathione and glutathione enzymes. So again, this is a study that we've probably shown you before when we were talking about curcumin. Relatively small amounts, so 400 milligrams long vida curcumin, so that equates to about 100 milligrams of curcumin itself. In generally healthy people, has been shown to upregulate various antioxidant enzymes, including catalase at the bottom, but generally increasing the whole kind of antioxidant status. Also lowers things like triglycerides, ALT, which is a marker of our liver injury. So it's kind of like looking after all of these wonderful pathways. Some of the product features of our long vida optimized curcumin is that delivers free curcumin, crosses the blood-brain barrier, and when we compare it to unformulated curcumin, it delivers 285 times greater bioavailability, is 7 times longer lasting, and it achieves plasma levels that are 65 times higher. So in terms of optimizing our curcumin intake and retention, long vida is the technology that does it. Okay, so moving on to membranes and antioxidant membranes. Okay, so this is quite a nice little simple diagram, really kind of clarifies different antioxidants, different functions, different areas. So we have things like vitamin E and beta carotene. So beta carotene kind of sits in this sort of like lake of fatty acids. Vitamin C sits on the outside, so it's protecting us from sort of the free radicals that are produced on the outside. And then we have this other wonderful antioxidant here called astaxanthin. Now, I gave a little webinar about a month ago, I think, on astaxanthin. So I'll just go over a little bit again. The wonderful aspect or the wonderful properties of astaxanthin is that it sits and spans. So, as I said, we've got vitamin E that kind of sticks in a little bit. We've got beta carotene that floats down the middle. We've got vitamin C on the outside. But astaxanthin spans the membrane. So not only is it kind of stabilizing and supporting our cell membrane, but we actually see protection against the damage of free radicals on the inside, the outside, and the, so inside the cell membrane, outside the cell membrane, and across the cell membrane as well. So it's offering this really kind of unique aspect to sort of antioxidant defense. So where do we get it? Okay, so astaxanthin is one of those kind of antioxidants that we don't make it ourselves. It belongs to a family of naturally occurring pigments called carotenoids. So you're familiar with those, beta carotene, lycopene, and so on. And then we've got the family that actually contain oxygen atoms. So we've got lutein, astaxanthin, so on. And astaxanthin is generally associated with things like marine animals. So, and flamingos. Flamingos is one of the best examples because flamingos eat these little single-celled green algae in which the astaxanthin kind of survives, and it's the pink-red sort of color of astaxanthin that actually gives the flamingos their sort of pink color. So flamingos hatch. The flamingo chicks hatch white, and once they start eating all the lovely little astaxanthin-rich algae, they start to accumulate it and they turn pink. So we see astaxanthin accumulation in marine foods such as salmon, crab, other crustaceans, and so on. Anything that basically lives on astaxanthin containing plankton. And then we can extract it and pop it into some supplements. So we actually use a particular type of astaxanthin called Astapure. There are several reasons for that. Firstly, it's one of the highest concentrations of astaxanthin. Astapure is grown in sort of closed system approach rather than to some other forms of astaxanthin that are grown in sort of like open ponds. So in terms of sort of, you know, protecting against contamination, Astapure is sort of, it's clean, it's concentrated, it gives a really good effective dose of astaxanthin. In terms of how powerful astaxanthin is, if we kind of move and look at the oxygen radical absorption capacity, or the ORAC value, which you're probably aware of, this is our method of measuring the in vitro antioxidant capacity of foods and supplements. The higher the ORAC score, the more effective your nutrient is in neutralizing free radicals. And my little diagram here, which you can probably make out, if you compare astaxanthin's scavenging capacity against things like alpha-lipoic acid, I've talked about EGCG, so green tea, catechins, CoQ10, vitamin C, and so on, it's about 6,000 times more potent. And this is to do with the amount of sort of like double bonds that it has within its cell membrane. So this is just another little kind of diagram here, really kind of showing how astaxanthin's polar ends overlap between the sort of membrane. And there's the kind of like emphasis here on this kind of like lightning rod conduction of electrons passing along the astaxanthin molecule, and they kind of get spat out. So not only does astaxanthin actually kind of degrade free radicals itself, but it actually kind of spits them out and passes them on to other antioxidants such as vitamin C, which sit just outside the cell membrane. So there's this kind of synergistic sort of communication that's going on between our antioxidants. Astaxanthin has numerous health benefits. A lot of the mechanisms are through kind of inflammatory pathways, so down-regulating nuclear factor kappa B, of course, COX inhibitor, down-regulates things like prostaglandins, lowers cytokines, interleukin-1 and so on, TNF-alpha. So astaxanthin, not only antioxidant, anti-inflammatory, crosses the blood-brain barrier and the blood-retinal barrier, so it promotes brain and eye health. So in terms of kind of recommendations, I suppose, if you're looking for a really good general overly protective, going to sort of like really look after your cell membranes, then astaxanthin is probably the top recommendation. Everyday well-being, 4 milligrams a day. So this would equate, so 4 milligrams equates to maybe 1 to 2 portions of sort of wild salmon. Medium intensity support 4 to 8, and then some of the kind of like studies looking at therapeutic support have optimized at about 8 milligrams a day. So it's you don't have to take a huge amount of astaxanthin to reap the benefits. And just sort of to clarify here, we put 42 milligrams of Astapure in to deliver 4 milligrams of astaxanthin, and it's bound to a kind of complex of other carotenoids in there as well. So there's a bit of beta carotene, which is a natural compilation of the astaxanthin itself. Okay, so what about our mitochondria? One of the biggest kind of like producers, if you like, of sort of free radicals, just as a sort of like natural process, really. Within our mitochondria, we have our electron transport chain. Within our electron transport chain, we've got our CoQ10. So I mentioned CoQ10 a little bit earlier on in terms of making sure our methylation pathways are working optimally, because if we don't look after those, then we're not going to be able to produce endogenously made CoQ10 if you're not getting it through your diet. Then, you know, levels are going to be low. And then we've got certain drugs like statins, which can compromise our capacity to make CoQ10. So actually making sure that we got a good healthy supply of CoQ10 is not only really important for ATP production, but actually as a way of protecting our mitochondria or mitochondrial produced free radicals. Okay, so just to sort of clarify here, again, is this kind of process of oxidized, reduced. So CoQ10, like many antioxidants, sits in these two forms. So ubiquinone, which is the oxidized form, ubiquinol, which is the reduced form. 96% of CoQ10 within the body is actually in the form of the ubiquinol. And so therefore, certainly in terms of sort of like antioxidant capacity and so on, ubiquinol is considered to be the active form. Now, because of the whole kind of oxidized reduced form, it's not surprising that actually getting ubiquinol in a supplement is a bit of a tricky one, because you expose it to air, it just oxidizes. So actually ubiquinol supplements haven't been, well, I was going to say haven't been around for very long, but looking at 2006, we're talking about 12 years. So they're still relatively kind of new, I guess. But they have been shown to be more absorbable than ubiquinone, so better for increasing CoQ10 levels. But they actually offer sort of better benefits in terms of things like neuroprotective benefits than ubiquinone supplements. Making CoQ10 ourselves it's complex, it's multi-step, and it's quite exhausting in terms of the amount of nutrients that you need or the building blocks that you need. Our levels of CoQ10 generally peak at around 20 to 30 years and then start to decline. So you need to be topping them up all the time. And the conversion, this kind of ability to go ubiquinone to ubiquinol also declines with age, and especially as free radicals accumulate. Interestingly, the majority of the dietary CoQ10 is in the form of ubiquinone. So unless, as I've said, you're eating lots of sort of organ meats, or if you're eating lots of fish, or if you're eating plenty of sort of CoQ10 containing foodstuffs, then your levels are likely to be less efficient or less, topped up than they should be. And hence, we have a wonderful Vesisorb ubiquinol product. So the Vesisorb part here is, and this is very similar again to a lot of these kind of nutrients, is ubiquinol in itself is large, it's bulky, it's not absorbed very efficiently. The Vesisorb part of this product essentially kind of converts the ubiquinol into a form that is then able to follow the natural sort of fat uptake pathway. So basically it shunts, the Vesisorb part shunts the ubiquinol through the cell walls and into the bloodstream where it's supposed to be. So the benefits of having Vesisorb ubiquinol versus standard ubiquinol is really about the amount that is actually delivered into the blood. So this is a study that was published a few years ago now, showing the delivery system, Vesisorb, increases blood plasma levels much more efficiently than standard. So that's an oil-based one that we have at the bottom. So taking Vesisorb delivered CoQ10 is absorbed faster, reaches concentrations that are quite sort of simply put, but stronger, and it stays in the body longer than generic delivery. And that's the kind of key thing. When you're looking at sort of benefits of various nutrients, the whole idea is that you want to get them into the system, you want them to be retained in the system, and you want them to be retained as long as possible. Just a few tips as well, just in case you weren't aware of it. So in terms of sort of antioxidant and energy support, anybody over the age of 40, if you're taking statins, then absolutely. Athletes, active people tend to sort of deplete. They also have sort of higher levels of free radicals, for example, and any kind of condition really that's related to high levels of oxidative stress. So there's a nice kind of list of inflammatory driven conditions there that would certainly benefit from antioxidant support specific to ubiquinol. And then Another little nutrient here, so you're probably all familiar with alpha-lipoic acid. This is another nutrient that's really useful for sort of mitochondrial support as well. Not only is it involved in cellular metabolism, but it's also a vital component of this kind of intracellular antioxidant cycle. So it's like cog-like sort of picture that I showed you earlier. So it scavenges a variety of free radicals, but it also plays a really, really important role in recycling vitamin C, vitamin E, and glutathione. And then we have our reduced form that regenerates other endogenous antioxidants. So it's the reduced form that's really important there. Incredibly important for things like stabilizing mitochondrial membranes, and then very similar to many of our other sort of nutrients talked about here, increases glutathione, upregulates transcription factor. So again, we're going back to our NRF2 pathway, and chelation as well. But one thing that ALA also does is that it increases GLUT4, so it's obviously then going to be related to sort of increased glucose uptake, favorable effects on things like insulin sensitivity. So really good if you have metabolic syndrome, type 2 diabetes, and so on. And some of the doses go a little bit higher in the case of ALA, in as much as 6 to, actually the doses range quite dramatically, actually anywhere between 6 and 120, dependent on the condition that you're looking at. Food intake reduces the bioavailability, and so recommendations generally say take it on an empty stomach. And then that's kind of the emphasis of our sort of antioxidant support kind of slides. The emphasis really is on understanding that antioxidant pathways are multiple and complex, and it's important to make sure that, you know, diet is optimized to be as diverse as possible. When it comes to, you know, supplemental support, rather than just kind of relying on, say, you know, okay, I'm going to take some vitamin C, I'm going to take some vitamin E, and that will sort of optimize everything. Actually, that's not always going to be the case. So actually having a sort of a good supply or mix and matching antioxidants is going to offer benefits that are superior to sort of supplementing with just singular antioxidants. Now, you're all probably very familiar with our Restore and Maintain protocol for sort of managing inflammation. We do suggest that, you know, if you're taking omega-3 fatty acids, it's a really good idea to sort of just co-supplement some good quality antioxidants as well. That will help to support both antioxidant and anti-inflammatory pathways. And just to kind of sort of see us out, if you like, in terms of blending antioxidants and nutrients that are going to support antioxidant pathways and help to sort of like keep our inflammatory sort of pathways in check as well. We have a wonderful product called Mind Care Protect. It kind of sits on our shelves, and, you know, we like it. But actually, if we look at the nutrients in it, they just kind of, the synergy of this product is really remarkable in terms of the ingredients that we have in there. So it's evidence-based. We've got a good array of sort of micronutrients in terms of things like selenium and zinc. Both, again, these are nutrients that upregulate glutathione. I've talked about resveratrol. So again, it increases antioxidant enzyme pathways, offers neuroprotection. We've got alpha-lipoic acid, which is our antioxidant, again, sort of recycling. Acetylcysteine, our precursor to glutathione, you know, and then you've got a full B complex in there to help look after your methylation pathways. And a wonderful omega-3. So you're getting 660 milligrams of omega-3 there as well. So that's the end of our antioxidant support webinar. I hope you found it educational and interesting. And I believe that Sophie may well be answering questions. I've just opened up my chat. So yes, so Sophie's doing a wonderful job of answering all the questions that are coming in. Thank you ever so much, everybody, for taking out your lunch hour. Sophie's just asking us some questions, I think. Okay. I'm just going to have a look. Questions in the Q&A. I found them.